qualification is MSc BA. I was working from since 2004 till last year in Bangalore, Banaswadi Marimilian School. Recently I shifted to Shimoga and I joined to this institution, Delhi International School. I have got vast experience from the year 2004 as physics and maths teacher. Here in this school, I will be working as a maths teacher and for some classes as a science teacher. Good morning students, this is Jagdish. I am going to take your mathematics. I hope you got the textbook, had gone through the contents that are there in that textbook, right? So what is the first lesson you have in that? It is rational numbers. When rational number comes into your mind, you studied different types of numbers in your lower class, that is in 6th standard as well as 7th standard. What are the different types of numbers you studied? You studied, yes, natural numbers, then integers, whole numbers, then comes what is called as rational numbers. Before go to the definition, just I will recollect what are the different types of numbers that you studied in your lower class. That is, first one is natural numbers. The numbers which are used for counting, such as 1, 2, 3, 4, so on, are called as natural numbers. Natural numbers are denoted by capital N. And the next set of numbers are whole numbers. Along with these natural numbers, you will get another number called as 0. 0, 1, 2, 3, so on forms a set of whole numbers. So natural numbers including 0 are called as whole numbers. Next, we come to integers. Integers are denoted by I. How we can represent your integers? Integers are those numbers which will have positive natural numbers, negative natural numbers along with this 0. That is, whole numbers along with the negative natural numbers means we don't have negative natural numbers. So negative numbers forms a set of integers. That is, -4, -3, -2, -1, 0, +1, 2, 3, 4, so on forms a set of integers. You have studied all this in your lower class and sums related to this, addition, multiplication, subtraction, those binary operations and representation of these numbers on the number line. Right? So, after this, the next type of number is rational number. The lesson that you have is rational number. This also you learn a little bit in your 6th standard. Now, what are rational numbers? The numbers which are possible to express. The numbers which are possible to express in the form of P by Q, where P comma Q belongs to I. That is, P and Q should be an integer, where Q should not be equal to 0. Such type of numbers are called as rational numbers. Rational numbers are denoted by this symbol. Usually rational numbers are denoted by Q. I repeat the definition of rational number. The numbers which are possible to express in the form of P by Q, where P comma Q belongs to integers and Q should not be equal to 0. Such a type of numbers are called as rational numbers and are denoted by capital Q. Now, you studied representation of rational numbers, addition, subtraction, those binary operations in 6th standard. Alright. Now, these numbers, that is natural numbers, whole numbers, integers, including this rational numbers, obeys certain properties that are properties of rational numbers. So, we will discuss that part in this class. Now, what are the basic properties you learned in your class? That is closure property, commutative property, associative property, distributive property. Right? What is closure property? So, for any two numbers, let it be A and B. Right? Any two numbers, addition is closed. Means A plus B is equal to, you will get some number C. So, that belongs to your rational numbers. That's naturally. See, for example, 2 plus 3 is equal to 5. 5 is again a rational number. Some fractions will take half plus 3 by 4. Right? In order to make it easy, I will take and choose 1 by 4 plus 3 by 4. What is 1 by 4 plus 3 by 4? It will give you 1. Again, it belongs to a rational number. Right? So, rational numbers are closed under addition. Similarly, we will go to subtraction. This is rational numbers are closed under addition. So, same procedure we apply to the subtraction. Whether they are closed under subtraction, shall we check? Yes, they are closed. Now, A minus B is equal to C. Choose your own number, that is 5 minus 10 is equal to minus 5. Minus 5 belongs to rational number. Hence, it is closed. Alright. Now, consider for multiplication. So, 5 into 10 is 50. Or else minus 6 into 11 will give you minus 66. All these numbers are belongs to rational numbers. Hence, it is closed under multiplication, addition also, subtraction also, multiplication also. Shall we check for division? Yes. So, for the division to check, okay, consider any two numbers, 6 and 7. Right? 6 divided by 7, that is 6 divided by 7, it belongs to, it gives you some number, it belongs to a rational number. That is 2. Right? So, as the definition says, it should be in the form of P by Q, but Q should not be equal to 0. When you come to the other numbers such as 7 divided by 0, it does not belong to rational number. This is indeterminate. It is not possible to find. Hence, rational numbers are not closed. Rational numbers are not closed under division. They are not closed under division. Rational numbers are closed under addition, subtraction, multiplication. I repeat, by considering any two numbers, it is possible to show that sum of any two rational number is again a rational number, subtraction of two rational number is again a rational number, multiplication of any two rational number is again a rational number, but division of any two rational number is not a rational number. Hence, rational number satisfies closure property under addition, subtraction, multiplication, but not under division. Similarly, we will go for commutative property. What is commutative property? So generally commutative property is A for any two numbers, A plus B is equal to B plus A. This is for commutative property and addition. Similarly for subtraction, A minus B is equal to B minus A. Then 3 A into B is equal to B into A. Fourth one, A divided by B is equal to B divided by A. So select any two numbers for A and B. So we will find that sum of any two rational number, again it becomes a rational number by adding them in a reverse order also. So but when we subtract rational number in the reverse order, it is not possible to get the same. So as the result of that, it is not commutative under subtraction, and it is commutative under multiplication. Again, it is not commutative under division. We will solve by giving some examples this problem. Alright, I will choose for A and B. A is equal to 5, B is equal to 6. Now, according to this, 5 plus 6 is equal to 6 plus 5. Will gives you what? 11 is equal to 11. Same thing here. 5 minus 6 is equal to 6 minus 5. 5 minus 6 is minus 1. 6 minus 1 is plus 1. Hence, it is not closed. Sorry, it is not commutative. It is commutative, whereas subtraction is not commutative. Similarly, select any other numbers for A and B. I will do this one. So, okay, for A I am going to take it as minus 10 and B is equal to 2 by 3, 2 by 5. Okay, so now we will do the multiplication process. That is, minus 10 into 2 by 5 is equal to 2 by 5 into minus 10. Alright. 5 divides 10 2 times. 2 to the side is minus 4. Similarly, 5 divides 10 2 times. 2 into 2 is 4. Since plus into minus, it is minus 4. Hence, it is commutative under multiplication also. But for the division, as you applied in your closure property, same procedure. If you consider in the form of p by q, q should not be equal to 0. As q is a rational, 0 is a rational number. When we take rational number 0 as q part, it is not possible to obtain this property. Hence, it is not commutative under division. So we have some more properties like associative property, distributive property, multiplicative identity, and additive identity, multiplicative inverse, additive inverse in this next part of the lesson. So we will see that in the next class. Thank you. All the best.